So chapter one is primarily about functions. The beginning part of the notes is about problem solving in general, and scatter plots and best fit equations. So the first target is very general. I can use mathematical models to solve problems. And the book starts out this way about just like problem solving steps in general. So this is not something that you have to do every problem that we do all year, but it's just some general problem solving steps that are good, whether you're doing a math problem or some other kind of problem. And so we'll just talk about this. And Poya is the guy who's responsible for these specific steps. He's a mathematician. He's not that old. He's not like from 2,000 years ago. I can look him up. I figure out, I can't remember how old he is, but he's, from the last 100 years. So his first step is to understand the problem, which sounds easy enough. And I'll relate this a little bit to, you taking tests. And also, sometimes I'll talk about math team because I think this is a good example of this. A lot of times I'll have to do a math team problem that I've never seen before. And I'll have to read the problem 2 or 3 times just to understand what exactly are they asking me to do. And it might be that case where you have to read a problem a bunch of times. You might see a vocabulary word that you're not sure about. And so understanding the problem is not always as easy as just reading it and automatically saying, okay, well, I get what they're asking. Sometimes people read a problem, they misunderstand the problem, they do all the steps and get an answer that would make sense, but they didn't do the problem that was being asked. So what I always tell people on tests is when you check your answers, don't just check your work. A lot of times people, they look through all their work and look if it's right. What I always tell people is when you're checking your tests, read the question and ask yourself, did I answer what they are asking me to? Because sometimes people do a problem that's totally different than what was being asked in the first place. Like the problem says, use the quadratic formula, blah, 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 and the person doesn't even do quadratic formula. So rereading the problem when you're done is part of this and understanding it in the first place. Okay, step 2 is devise a plan, which is very general. Your plan could be to make a graph. Your plan could be to make an equation. Your plan could be to guess and check. Your plan could be to factor. Your plan could be to make a table. There's a lot of plans out there. And you might have a terrible plan. But it's better to have a bad plan than no plan. And so this is not saying make the right plan. It's saying make a plan. Okay? And step 3 is carry out the plan. If your plan is to make a table, then do that. If your plan is to guess and check, give it a shot. Okay? And then step 4 is look back. You get an answer, you ask yourself, am I answering what they're asking? And if not, then re-understand the problem, make a new plan, try that plan, and keep going in circles until you get it. Obviously the goal is not to do a problem 100 times, but those are general problem solving steps. And no one's gonna read that and be like, oh, well, now I can just solve any problem in the world. It's not, there's no steps that will get you to every problem. There's no algorithm to solve any problem. But that's how the book kind of starts. And so I wrote a problem that, I think that everybody could figure out given enough time. And so I want you to take some time, read the problem, come up with a plan, and do what you can. Do you have a question?
Yeah.
Is it? So, an integer is any number that that doesn't need to be written as a fraction. So if you think about a number line, you have 0, 1, 2, 3, 4, and then going the opposite way, -1, -2, -3, those are integers. They're different than whole numbers because whole numbers can't be negative.
Okay.
if you think you have it, you can kind of show me what you think, and I'll not say anything, but if anybody wants to just show me what they got, see if anybody has figured this out. Okay, I'm not gonna say anything, I'm just gonna see for my own, knowledge of how much more time people need. This is not an easy problem. While people are working, do you know what consecutive means? Yeah, like in the alphabet, B, C, D are consecutive letters, and so consecutive numbers would be in order, but this says consecutive even numbers. I see a lot of people trying equations. It's a good plan. It's not the only way to do the problem. So if your equation isn't working for you, try something else. So I'm not going to give you the answer, but I saw a lot of this where people were saying 2 times the first integer, 3 times the second integer, and the third integer is 34. But this doesn't really get you very far, does it? Because of the fact that you got 3 variables and you got no other information here. So you can't like solve this. Okay, without telling me the answer, somebody want to explain anything that they did that might be helpful. Nate, what'd you do?
Y is 2 plus x.
Okay, and then what'd you make z?
4 plus x.
4 plus x, okay. So, this is one of the 2 ways that most people do this. Nate said, let's make this, let me erase this and then explain what it is. He made the first integer x, and then he made the next integer 2 bigger than that. He doesn't know what that first number is. It could be the even number 10, but he knows the next one is consecutive and it's even. So to be 3 consecutive even integers, one's got to be 2 higher than the first, and the other one's got to be 4 higher than the last. So this is one way to start the problem, is by doing that. And then I'm guessing, Nate, you did 2x plus 3 times x plus 2 plus x plus 4 equals 34?
Yeah.
Okay, and when you solve this, you can just trust me, you get x equals 4. Okay? And then, Nate, what are the answers?
4, 6, and 8.
4, 6, and 8. Okay. You get that by doing 4 plus 2 and 4 plus 4. Let me ask you this question. Would it have worked if I did n minus 2, and n plus 2? That would have worked. There's no reason you have to do that. There might be occasions in math where this is better, but on this problem, most people probably wouldn't do that. But that would work. That would be okay. You could have done x minus 4, x minus 2, and x. That would have worked also. you know, in one case you get the middle number, one case you get the big number. The way we did it, we got the smaller number. Did anybody get this any other way? A totally different way. Go ahead.
I just guessed and like figured it out.
Yeah, exactly. Because when you're guessing and checking, you're not guessing random numbers. The first number you would guess would be 2. And if that doesn't work, the next number you guess would be 4. And 4 works, right? Because you're guessing even numbers. And then you just check to see if that equation that you had worked. So 4, 6, and 8 are the answers. And some people didn't quite get there because I didn't maybe give you enough time. But guess and check and make an equation were the two main ways to try that. You're going to try these 2 problems in your groups. Only do 2 and 3.